Welcome, everybody, to Let's Talk Computer Science, a podcast dedicated to talking about the past, present, and future of computer science. Of course, this podcast is made possible from our amazing friends at VEX Academy. Be sure to check out their amazing CS platform, including courses on cybersecurity and all the rage in education right now, AI. Don't have a teacher, not a problem. Rex is now providing instructors as part of their platform. So be sure to check them out at rex.academy. And today I'm excited to have on the show Jason McKenna. He's the Global Director of Educational Strategy at VEX Robotics and author of the book, What STEM Can Do For You. That book just came out, right, Jason?
It did. It started shipping out in February.
That's awesome.
Thank you.
Tell me, first of all, a little bit about your job, Global Director of Educational Strategy. It's an amazing title. What do you do? What do you do every day?
Oh, wow. I do something different every day, actually, but no, I have a great job, and I'm very privileged to have this job. One of the best perks about my job is I'm able to talk to educators all over the world. One of the things that I've talked to and I've talked about STEM and computer science education on every continent, with the exception of Antarctica. So that's a nice little perk for my job, and that's because of the reach of VEX Robotics. We like to say that we're the largest STEM education company in the world. We have offices in the UK and Australia, all throughout Southeast Asia. So we're very proud of that fact. We also have an office in Canada besides our ones here in the US. So we're very proud of that fact. But we have a continuum of products that span from kindergarten all the way through college. So the main crux of my job is making sure that teachers have the resources that they need to integrate our tools and our solutions into their classrooms, whether that's around curriculum, whether that's around teacher professional development, whether that's around populating things like our VEX library with articles and resources to help them be able to do that. Doing presentations and going and actually talking and meeting with the teachers to find out what it is that they need and what we can create to make better, to make the classroom experience more meaningful for them. The VEX Code coding software that powers all of our robots, all of that comes out of our office, and that's
So I want to
what
tackle
I'm
that in just a
dealing with
second and
every
talk
single
about some
day.
of the challenges around getting this introduced into classrooms and curriculum across the country. But before we do that, I want to hear a little bit more your origin story. Like, what got you excited and motivated to be where you are today?
Mhm.
Like, was there something or an aha moment in your childhood or maybe in your early career where you're like, maybe robotics, STEM, and all this stuff's not too bad. Maybe it's not going away. Yeah.
Yeah. No, it's a great question. The story I tell people all the time is I'm not a tinkerer, I'm not an engineer, and I'm not a coder. I'm a former classroom teacher. I taught for 20 years at a small school right outside of Pittsburgh, Pennsylvania. And the last few years that I taught, I was put in charge of our school's enrichment program, our gifted
Yes.
program. And because I was in Pittsburgh, Carnegie Mellon used to offer a summer camp called Sea Mites. They don't do it anymore, but they used to offer that camp, and all of my students went and did that camp. So when I got put in charge of the enrichment program, all of my students wanted to learn coding and they wanted to code robots, which neither of which I had any idea how to do about. So the Carnegie Mellon Robotics Academy actually offered both curriculum and training on teaching and coding with the robot. At the time, the head of the Robotics Academy was a gentleman by the name of Robin Shoup, who was a former shop teacher in Pittsburgh Public Schools. And he basically took a liking to me because at the Robotics Academy, there were researchers, there were engineers, both software, mechanical engineers, but there weren't really any classroom teachers. And he liked me because I was a classroom teacher, and he kind of liked the perspective that I had. So basically, he asked if I wanted to start come during the summers to, help develop curriculum and do some of the things that they were doing, which I did. And that kind of slowly led to me leaving the classroom and then joining VEX, where I'm at right now. The light bulb moment, though, that you mentioned, again, in my free time now, I'm not coding, but the light bulb moment for me was there were things that I was doing
Okay.
in my classroom that I always struggled with. Group
Right.
work is an example of one. Getting students to collaborate authentically and well together, finding multiple solutions to problems, students being focused on iterating and not being discouraged by failure, but instead just viewing that as feedback in the learning process. All these things that I got hired to teach in 1997. None of those things are particularly new, but they're still very difficult to do. And these were all the things I was being asked to do, which when in a traditional math class or a science class, language arts class, I had a very difficult time doing. When I started incorporating robotics and students were the story I tell in my book is I asked my students to code the robot to move in a square. And I had 6 different solutions to that. So there were 6 different ways that my students coded their robot to move in the square. Some of them had the robot move in centimeters, others had them move in millimeters. Some had them do a swing turn, some had to do a point turn, some did it at different velocities. So there's all, and we had a very robust conversation where it was like, "Well, why did you choose that? And why did you use this?" And that was something I had struggled to do so much in my regular classroom. That was the big aha for me. And I was like, I love this. This is fantastic. This is what I've been trying to do. And this, it was
So a lot
so
of different
easy
points
to
to pick
do
up
with
on
this
there. One is that you and I both
introductory
came into teaching around the
robotics
same time because
lesson.
I was 98. Was when I started teaching. But also, I've written a book on failure and risk taking. And one of the big things I talk
Okay.
about is iteration and the fact that there's not always one right answer. And sometimes the process is more important than the product, right? All the things you were just talking about there. So let's go back to a question I was going to ask you
Mhm.
earlier, which is the challenges of kind of integrating all of this. So I know a lot of times with STEM and robotics in particular, it's like maybe it's an elective class, or maybe it's a, well, we're gonna do, like you talked about, a summer camp, or maybe it's an after school, or how do we get it, or what are some of the challenges in getting it embedded into classrooms day to day, and what are you seeing out there that has been successful in terms of getting that kind of embedded?
Yeah, the great question. So I think that the challenge is exactly what you just mentioned. There's still a lot of, for lack of a better term, controversy
Forever,
around
it
the
seems
best
like. Yeah.
ways to teach reading. We've been teaching reading for a long time. Yeah, and so with computer science being so new, what exactly is the best way for us to do it? And unfortunately, what you're seeing a lot of right now is
Mm,
we're confusing quantity with quality. So I have computer science being taught to all of my students, and great, we should
mm,
congratulate that. But is it actually being taught well? One of the big things, I read a lot of the work by Mark Gusdile, and he wrote an article in the ACM magazine a few months ago, and he talked about this notion of should we be teaching kids Python? Should we be teaching kids JavaScript? Should we be teaching kids this particular language or that? And he said, who cares? And the reason why he said who cares is because our goal is not that all students go on and get a job in computer science or go on and major in computer science. Our goal is that all students are exposed to computer science, just like all students are exposed to biology and all students are exposed to physical science. We feel like it's important, and we feel like it's important for our students to be exposed because obviously computer science and STEM is ubiquitous in their lives. So to be, basically a well-informed citizen, to be able to talk about things like AI intelligently, we have to know a little bit about it. So I think that is really the challenge: is number one, understanding why computer science for all? Like, why are we doing this? Number two, really believing that computer science is for all. And then number three, creating the infrastructure in our schools and actually be able to accomplish that. Now, your second part of your question was like examples around implementation. There's a couple of them going on really well right now that I could speak of specifically. One is in a school
mm.
district in Henry County, Georgia, which is right outside of Atlanta. They're implementing STEM, I'm happy to say, with VEX across their entire continuum of students, kindergarten through 12th grade. And what they've done is they've actually figured out a way, and they figured out the lessons
Nice.
to integrate STEM as part of the regular school day. So it's not an add-on, it's not an extracurricular activity, but they are using like VEX Go, for example, to make the examination of life science more interesting, more meaningful to the students, and to make it more hands-on and engaging. They're using VEX 123 to identify different sounds and phonics as they're teaching reading to very young students. And they're taking it essentially off of a worksheet and making it more collaborative, and they're making it more engaging for the students as a result of that. And what they've done from an administrative level is they prepared all those lessons because teachers are busy. So you can't expect teachers to do it all on their own. They figured out the integration points, prepared the lessons from an administrative level, and then they went ahead and they implemented it. And when you talk to them about it, they will say that what about
Right.
what about teachers owning this? What about giving teachers some autonomy over this? And he said that's important,
Right.
but
Yeah.
teachers are so overwhelmed right now. How can they actually do that? So you have to find this balance between teacher autonomy, but also give them the tools they need to be successful. So that's one great example of an implementation of that. And then the second one is local to us in Pittsburgh, Woodland Hills. Highly urban school district. Majority of the students are on free and reduced lunch. Same idea where they were able to implement STEM K to 12 across the entire continuum of students. Same concept. They were able to integrate it into the regular school day, find out the best places where they were able to do it, and then do it. And they kind of took the kind of a combination of what I talked about in Henry County, where they have a few teacher leaders, where essentially the teachers were able to figure out the best entry points. They made the scope and sequence, and now they're the ones communicating with the other teachers to be able to implement it and be able to implement it effectively. But their leadership, Dr. Castagna and Mr. Wilson over at Woodland Hills, really had this vision of every student being exposed to it, which kind of goes back to my earlier point, like what does CS for all actually mean, or STEM for all? So making sure that every student was actually exposed to
I
it and
love
then
those
finding the
examples, and you
means to
talk,
be
and
able
they're
to
different
achieve it.
angles of approach, because I think going back to your early statement about quantity, sometimes we did the hour of code. Remember when that was the thing? All right, we're gonna do an hour of code. Everyone's gonna do it. We're all gonna do it.
Yeah,
It may be
yeah,
good, maybe bad, but we're all doing it. And then
yeah,
it became a week of code, a month of code,
yeah,
whatever. But you're right. Was it really
yeah.
actually any good? And now you have schools that are doing it with fidelity, whether it be leadership driven, like in the case of Henry County. But then I love that idea of the vanguard teachers, those teachers that are out front, kind of integrating like they're doing in Woodland Hills, that kind of
Yeah.
idea of like, because to me, when I work with teachers, it's like, it's great they hear from me. I'm a talking head. I love technology. They know I'm into it. But when their colleagues share it, that's when I think it catches fire.
And that's exactly right. And I'll plug our conference here at VEX Worlds this year. You know, VEX got started in the competition space. The famous story is our two founders started mentoring a high school robotics team in their garage, right? And that's how we got started to where we're at right now. But competitions is something that we'll always be involved in, and those after school competitions that students do. Well, what we're attaching on to that this year is April 27th through the 29th is the VEX Educators Conference at VEX Worlds. And the reason why we're doing that is for what you just said, and the research backs you up on this very, very clearly. Teachers work the best
Right.
with other teachers, and that's how they learn. Gentleman's name, I hope I'm getting this right, Justin Reich,
Right. Oh, I know
Reich, wrote
Justin
a
Reich. Yeah.
fantastic book about this.
Yep.
Yeah, thank you for correcting me. In which he said, COVID should have been the time when educational technology shined.
Should have.
It should have been the time where we've invested all of this into ed tech. Now students are remote. So what? The scores should still continue to go up. Students should still be able to learn. And that didn't happen. So why didn't it happen? The argument, the assertion in his book is it's very persuasive. He talks about the fact that change has to occur at the teacher level. The context of the individual classroom, the culture of the individual classroom, it has to be individualized for that teacher and for his or her students. And that's how you're actually able to impact change, not from the top down from an educational technology perspective. So that's what we're trying to do at our conference is bring educators together and allow them to have those conversations that you just talked about, so they can see the best way to implement STEM or
And
computer
remind us
science
the
into their
date and
classroom.
location of that.
April 27th through the 29th. It's in Dallas, Texas at the KB Hutchinson Center. That's where VEX Worlds is, and that's where we'll be having our conference. And you can go to conference.vex.com to find out more information about it, or just email me at jason
And
at
we'll make sure, folks,
vex.com.
those of you listening out there, we'll put this into the show description notes as well, because this podcast, I believe, will be out probably about 3 weeks prior to that, if I remember correctly. So perfect timing on that. One more quick question as we wrap up, and this is a bigger question. I don't know how much you could answer to it in terms of VEX's philosophy around it, but when we talk about equity and access in schools, robotics
Mhm.
sometimes can be for those privileged few that have maybe the funds or the access to it, right?
Yeah,
I
yeah,
remember VEX when
yeah.
we started in our schools at Westlake. It was like we had a few of these great robots using VEX all the way through our middle schools. We loved it, and I realized that we were lucky and fortunate to do it. What are some of the things that VEX is doing, like as a company, to make sure that outreach kind of goes beyond just the schools that have maybe the finances and the money for it?
Great question. And as I mentioned at the very beginning, or I mentioned a few minutes ago, excuse me, VEX got started mentoring those high school robotics, and those were the big,
I
huge metal
remember those things. Yeah.
robots, right? Which are
Oh yeah.
expensive and it requires a certain amount of know-how to be able to do. So what we've done, over the course of really the last 3 years is bring the price point of our robots down and also lower the barrier of entry. So now I can purchase a VEX Go kit for, $290, as opposed to those metal robotics kits were going to cost you into the thousands of dollars. We also, during the pandemic, released VEX Code VR, which is free. And there's still sections of VEX Code VR which are free right now. To get to the purpose of that was to keep students engaged with STEM education during the pandemic when they could no longer do the hands-on collaboration in the classroom, obviously. And that's been more successful than we ever could have imagined it being. And we're dedicated to maintaining a certain portion of that. I think it's around 12 of the playgrounds on VEX Code VR that will continue to be free as a result of that. Free teacher professional development. The curriculum that you use with the robotics will always be free. VEX Code, the programming software, will also always be free. And then trying to do things like these VEX Educators Conference and try to basically enabling teachers and amplifying their voice about what is actually successful in their classroom and what they've been able to do, not only from a student perspective in terms of what was a meaningful experience for the students, but also, as you mentioned, from an equity and access perspective. What can we actually do, and how can we actually make sure that's impactful? But we still have a ways
Right.
to go. We do not have all the answers. We're working with different people right now around things like making VEX Code more accessible. How can we make sure, from a curriculum standpoint, that we have fidelity to things like universal
Mhm.
design for learning and that type of things, to make sure that we're doing all that. So we have done some things. We've worked very hard at it, but we still have some ways to go, and we're committed to continue to
Well,
work
it's
at
one of
it.
the things I've always admired about your company is that ability to kind of continue to grow and actually believe in what you're actually teaching, which is let's continue to iterate and improve and collaborate. Because a lot of people hear CS and they think coder sitting behind a screen by him or
Yeah,
herself, where the
yeah, a
reality,
white guy in a hoodie.
yeah,
Yeah,
usually a hoodie, right? But the reality
yeah,
is, like, in everything that you're talking about, I hear the word collaboration quite a bit. When I've seen these
yeah,
team competitions, it is amazing the amount. And by the way, failure, a big part of those competitions, right? Yeah,
absolutely,
recover from that
100%.
failure and learn from it. So, where can people find out more about you and your great work?
So, if you want to find out like more about my book, for example, you can go to my site, jmckenna.org. If you want to find out more about VEX Robotics, you can go to vexrobotics.com. If you want to find out more about the conferences I just mentioned, you go to conference.vex.com. You can follow me on Twitter at McKennaJ72, and you can always shoot me an email, jason@vex.com.
That's awesome. Jason McKenna, everybody, check out the book, What STEM Can Do for You. It is can do for your classroom, excuse me. It is available on Amazon right now as a release of this podcast. And Jason, thank you so much for being a part of the Let's Talk Computer Science podcast. And again, thanks to our friends at Rex Academy for making this podcast possible. Be sure to check out their platform at rex.academy. We all know technology will be a part of our future. And as educators and leaders, it's our role to make sure that that means all students, have opportunity to that future as well. This is Carl Hooker signing off.